Fine. So today we are going to start multicast routing, right? So because today we are going to start this multicast routing, so we must understand multicast routing protocols, right? So we are going to start now. PIM, protocol independent multicast, and it is a multicast routing protocol actually. Apart from PIM, we are also having some other various multicast routing protocols too, such as DVMRP, MOSPF, CBT, right? So all these protocols are also known as multicast routing protocols. But those multicast routing protocols were having their dependencies onto unicast routing protocols as well. Like MOSPF was depending on OSPF, you understand? DVMRP was depending on distance vector routing protocol. So I mean, over there, in all those multicast routing protocols, we were having some dependencies. Finally, they launched PIM, protocol independent multicast, which means that it will never depend on any unicast routing protocol. This PIM is not going to be depend on any other, on any unicast routing protocol. Whatever you are running, even if you have configured static routing, then also PIM can perform, right? So that's why its name is protocol independent multicast, right? So basically PIM is one of the multicast routing protocols, and it is an open standard, you understand? It is an open standard, and apart from it, it uses multicast address 224.0.0.13 for itself, such as like EIGRP was using .10. In same manner, PIM will use this 224.0.0.13 as multicast, to multicast its messages, because inside PIM itself we will be having some types of messages like hello is there. So I will be discussing all those types of messages available in PIM as well, but before that you just need to know that PIM itself will multicast its messages towards its PIM neighbors, right? So it will be using this multicast address to multicast its messages, and because same as EIGRP, PIM will also hand over its payload to directly IP itself. It will not use either TCP or UDP. It will directly hand over its payload to IP itself. It means that PIM must have its IP protocol number. PIM must have its IP protocol number. So what I remember that its IP protocol number is, I think 112, something like that. I don't remember exactly, but we can cross check it, right? We will see that which protocol number is used by PIM. So but I think it's 112. We can check it out, right? Or was that? I don't really remember it. We will see that, but what I remember that it is 112. Fine. So but finally thing is, like, it will be using IP protocol number. It will never use any port number, right? Fine. Now if we talk about PIM, in PIM we are having mainly two modes: dense mode and sparse mode. We are also having a combination of dense and sparse mode as well. Sparse and dense mode, but we will not talk about the combination of sparse and dense mode. First of all, we just need to understand that what are the differences in between dense mode and sparse mode. And first of all, I'll teach you dense mode, and then after I'll go for sparse mode. However, before going to implement this dense mode, I'll teach you that what are the differences in between dense mode and sparse mode, right? So basically PIM can be configured into two modes. You can configure it into two different modes, like you can configure it in dense mode as well as you can configure it in sparse mode. Fine. Now you must remember that if you talk about multicast routing, in multicast routing it will always form a tree. Do you remember that OSPF was forming a tree which was known as SPT, shortest path tree? In same manner, in multicast routing also, one more thing that I would like to tell you, that a router which is near to source originator, who is originating multicast stream, let's say that this is R1, this is R2, this is R3, there is a server, it is originating one multicast stream for multicast address 230.1.1.10, let's say. So for this router, R1 would be upstream and this R3 will be downstream. Means a router which is near to source of the multicast stream will always be known as upstream router, and a router which is which is far from the source will always known as downstream. So for R2, this R1 will always be known as upstream router and this R3 will always be known as downstream router. So please don't get confused while I'm saying that okay, it will send this message to its upstream router. Upstream means upstream, right? It's same as like STP, spanning tree protocol. Fine. Then after it, I was telling you that there are, in multicast routing also there will be some trees. It will form some trees, right? So those trees are basically known as, like, one is known as source based tree, one is known as shared tree. So basically these two types of trees will form in your multicast routing. It can form source based tree or it can form shared tree, and it is also known as root path tree. You understand? Now first of all, I'll teach you that what is the meaning by source based tree. What is the meaning by source based tree, right? So let's try to understand it now. If you talk about a source based tree in multicast routing, let's say this is R1, this is R2, and this is what? R3. Let's say there is a server which is source and it is generating multicast stream for 224, sorry, let's say it's 230.1.1.10 and its IP address is like 1.10, and here let's say gateway's address is what? Here is 12.1.1.223. Fine. If you are using source based tree, in it what will happen, that whenever this R1 will receive this traffic over here, this, PIM neighborship must be there, right? PIM neighborship is there, PIM is running in between routers. Fine. R1 will receive this multicast packet onto this interface. It will immediately create a S,G entry where this S means source, G means group address, where S means source address and G means group address. So who is the source? It's 1.10, and for which group it is originating this multicast stream? 230.1.1.10. So now this R1 will immediately create this entry, that 192.168.1.10, 230.1.1.10. This is called S,G entry. And because it received it on FA 0 by 1 and this is, let's say, FA 0 by 0. So because it received it, this packet onto FA 0 by 1, so under there will be two things now under this entry, and under this S,G entry there will be two things. One, incoming interface list, and one will be outgoing interface list. Under incoming interface list you will always find maximum one interface. You cannot have more than one interface under incoming interface list, but definitely under OIL you can get multiple interfaces. What is the meaning by incoming interface list? Incoming interface list will contain that interface where your router received that multicast packet. So under IIL it will be FA 0 by 1 because R1 received this multicast packet onto 0 by 1, and immediately in source base tree actually this R1 will forward one copy of this packet towards R2 as well. So because it is forwarding this packet out from FA 0 by 0 as well, so under OIL it will be FA 0 by 0. In same manner R2 will receive this packet onto here, so it will also create S, G entry now in its M route table. It will also create S, G entry in its M route table, and then this 0 by 0 will be under IIL incoming interface list, and 0 by 1 will be under OIL. In same manner R3 will also create S, G entry. Fine. Now in case if there is a user, it wants to join 230.1.1.10, so it will generate a report message. Do you remember that in IGMP it will generate a report message? Yesterday I explained you that I want to join this group, but this PC doesn't know anything related to source, right? So it will create star, G entry now in its M route table, this R3, that, and will put this interface into OIL, that I have to forward traffic out from this interface, this one, let's say this is 0 by 1, for this group address. Now it will perform routing lookup in its M route table, if it have information about this group. So it was already having S, G entry in its M route table. You understand? See, there will be only two things: either it will be having that group information in its M route table, or it will not be having. If R3 do not have that group address in its M route table, then it will create a star, G entry and will be in silent mode. It will create simply star, G entry. Nothing. It will not perform anything else. But in case if it is already having S, G entry in its M route table, now this R3 will ask to its upstream to send the multicast stream. Then R2 will ask to its upstream router. You understand? So that finally this stream will come to R3, and this R3 will start to send it towards this user. So basically in source based tree, S, G entries will be created. In source based tree, what is happening? S, G entries are created. Fine. Now there is a small problem. To create S, G entry, first of all, router has to flood multicast packet throughout the network, because without receiving a multicast packet, routers cannot create S, G entry. So your multicast packet will be flooded out throughout the network without any reason. Might be that some of the routers, I mean, let's say that no one was having any group member, but still we have flooded out that packet towards or out from throughout the network, so that routers can generate S, G entries, right? So basically here routers are performing source based multicast routing. See, because all of them are having S, G entry, so now R3 knows very well that who is originating multicast stream for this group, because S, source, is always unicast address. That is why we always say that before going to implement multicast routing, you must verify that your unicast routing is working fine or not, because if unicast routing is not configured perfectly, multicast will never work. See, it is depending on source address now, and source address is what? Unicast address. So if source address is not reachable from R3, what will happen? Tell me. Have you understood my point or not? But there is a problem in this source based tree, and basically this source based tree is known as dense mode. This is dense mode. This dense mode will always create source based tree. Remember, dense mode will always create source based tree. Means that in dense mode you will always find S, G entries in your mroute table.
So if router receives a multicast streams, a router should receive that from 180 to 168.110, and so before putting that S, G entry into its route table, will it check its connectivity to the source?
Of course, definitely.
No, just before putting the entry or before
Putting entry in its mroute table, I will let you know. RPF check is there, right? Have you understood it? Or have you understood all these concepts now? Fine. Now in S, G, here in dense mode you can see that first of all this, is source based tree. Devices have to flood out your packets, multicast packets throughout the network unnecessarily. Doesn't matter that whether they are having group members or not, right? But first of all, initially your multicast packet will be flooded out throughout the network, just to create S, G entries in all routers and route table. You understand? Fine. Now there are some problems. See, it is not always necessary to have only one source for a single group. Let's say this source is generating multicast stream for this group address. Might be there are some other sources as well which are also responsible to generate multicast stream for same group. You cannot rely only on one server. Are you getting my point? You cannot rely only on one server. So if you are having multiple source for a single group, let's say there are 100 source for one group. So for one group, how many entries will be there? How many S, G entries will be there for one group? 100 entries will be there. 100 S, G entries will be there. If you are having 100 groups, for each group you are having 100 sources, how many entries will be there? 10,000 in your mroute table. If you are having 1,000 sources for a group and you are having 1,000 groups, you can examine that how many entries will be there. That's why we do not prefer to use source based tree. Then they proposed what? Shared tree. In it will create star, G entries, not S, G entry. In it will create star, G entries, not S, G. So if you are having multiple sources for a single group, then also there will be only one entry, because star means any. So main difference in between source based tree and shared tree is what? That in source based tree it will always create S, G entries. In shared tree it will always create a star, G entries. And why do we call it shared tree actually? See, if you are having shared tree in your network, let's say this is R1, R2, R3, R4, R5 and R6. You have to configure any single router as a meeting point. Let's say you have configured it as a meeting point, and basically this is known as RP, rendezvous point. This is known as RP as well, rendezvous point. Rendezvous point. You can also call it meeting point. And on all devices you have to configure this R2 is what? This 2222 is what? Meeting point. All of them must have this information. It means that all devices will share a single meeting point. So all of them will share this common device as a meeting point. All devices, right? So now you will call it shared tree. And here mechanism is quite different. Actually, if there is any source who is generating multicast stream, let's say this is source generating multicast stream for 230.1.1.100, it will not flood it out towards all. No, it will register itself on 2 RP only, meeting point, that I am a source for this group. That's it. Only and only RP will be having this information. Then after, if there is any lane user wants to join that group, then this router will also responsible to ask RP only, that I want to join this group now. And that is why we are calling it as a meeting point, because this RP will be responsible to connect these two different trees with each other. I mean to say, source will register itself on 2 RP, then a multicast receiver will also contact to its RP, and then RP will be responsible to interconnect, to join those two connections, is not it? So that is why we are calling it as a shared tree. And because traffic is coming via RP, so you can also call it RPT, root path tree, RPT, root path tree.
सर आखिरी आपको रन है तो उसके बाद का कोई नोटिस नहीं होगा.
Traffic has to go through them, so why will they do not have, I mean why will they not have that information? Fine, great. So we will be discussing in more details later on about it, because so many things are there to discuss in sparse mode, a lot of things. But first of all, we have to start from dense mode, right? I will start from dense mode. So let's start now. PIM dense mode. PIM dense mode. In dense mode, we are having some types of messages, same as EICRP have. Like here we are having hello, and you can also call it query, and by default its interval is 30 seconds periodically, and it will always multicast them with using multicast address. Tell me, 224.13, definitely. Second, it will send, I mean it will also have join prune message. Fine. And see, these two things are not different actually. This is a common message. Join and prune are not different messages. This is a common message, but in a single message we are having two different fields. One is for join, one is for prune. I will let you know that why do we have all these things over here, right? What is the uses of join message and what is the uses of prune message. Third, graph. And one more thing, join and prune messages will always be multicasted. Graph, we are also having graph acknowledgement. Unicast. and finally there will be a assert message. So these 5 types of messages will be in use in PIMdensemode. Fine. Join prune and hello, we have to discuss all these things now. Fine. What happens actually to form PIM neighborship in between two devices? To form PIM neighborship, it will send hello to each other, and also as a keep alive. It will use these hellos to form PIM neighborship as well as a keep alive. And by default interval is what? 30 seconds. Fine. It is also having some hold interval, and I think it's 1 minute or 30 seconds, something like that. I don't remember exactly. I will show you, right? Then we can check it out that what is the hold down time of a PIM, right? But hello interval is by default 30 seconds. You can change it as per your requirement, and this is different from IGMP, right? IGMP is running in between router and host only, lane user only, right? Group member only. Now PIM neighborship will come up with the help of hello messages. Let's say there is R3 as well, and there is a source. Basically dense mode, or you can say source based tree, works based on flood and prune method. Flood and prune method. Basically it uses concept of flood and prune, which means if source is generating any multicast stream, let's say 230.1.1.10, so this R1 will receive it over here. It will create S, G entry, will send one copy of that multicast packet towards its another PIM neighbors as well. Then R2 will receive that, create S, G entry, and will also forward a copy of that multicast packet towards all other PIM neighbors. So it will send it towards R3 now. As it will also create S, G entry. Now let's say that R3 do not have any group member into it. I mean R3 do not have any group member. So if this source keep on to send this multicast stream to R1, R1 keeps on to send this multicast stream to R2, R2 keeps on to send this multicast stream towards R3 without any group member, then there will be a unwanted wastage of network bandwidth. There will be unnecessary wastage of network bandwidth. And if network bandwidth wastage is there, then of course there will not be any advantage of implementing multicasting in your network, right? So to solve this problem now, here what happens in dense mode actually, that if R3 have came to know that it does not have any group member for this S, G entry, it will immediately send a prune message back towards its upstream router. It will send a prune message. That's what we were having, this type of message, right? Prune message, join prune, I told you, right? So R3 will send this prune message towards its upstream router, and which is this time R2. Which is this time this R2. R3 will send this prune message to R2, and then R2 will prune this interface out from OIL. However, it will keep that S, G entry over here, but it will prune this interface, right? It will not forward any multicast packet out from this interface. And then because R2 also do not have any group member for this group, so R2 will also send a prune message towards its upstream router. So prune message, right? So now R1 will receive prune for that S, G entry. So it will also put this interface, this one, which is going towards R2. It will also prune this interface, right? So R1 will stop to send this multicast stream towards now towards R2. You understand? Have you understood it or not? So basically all of them will prune themselves from their upstream router. Fine. Finally, R1 cannot send prune message to source server. You know why? Because PIM is not running in between this server and this router. Hello. Prune is a PIM based message, and PIM is not running in between this router 1 and this source device, source server. So R1 will keep on to receive this multicast stream. Fine, no problem. After it,
do these routers let that source G entry in their in-route table even if they have been closed?
of course. Otherwise, how will it be possible? Now see, in future, if there is a switch and then after you are having group member over here, it will send the ICMP report message to R3 that I want to join this group. So if they do not have S, G entries in their route table, then how will it be possible for R3 to ask source to send multicast traffic, multicast stream towards this
Is
R3?
there an interval for how long?
Of course, for all entries. Whenever a router will put any entry in its route table, it will create, it will also run its timer. That is why this R1, see, it is not that it will never send this multicast packet towards now R2, and R2 also will never send it towards R3. No, there is a specific time interval. After that, after the expiration of that time interval, R1 will again send that multicast packet, so that other routers can come to know that okay, source is still generating multicast stream for this group. And they will also refresh their S, G entries, and once again they will prune themselves. But in case, let's say that all of them have pruned themselves, right? Now this group member have came up. It will send a report message to R3. R3 will see that okay, S, G entry is there for this group, and it is my upstream is what? How will it be possible for R3 to know that okay, who is the upstream router? By looking at source router. By looking at source not source router, source IP address. It will perform lookup in its unicast routing table for this source, and accordingly, hello, next hop will always be upstream now, right? To reach this source address, the next hop address to reach this source address will always be your upstream router. So it will send a now graphed message. If it has pruned itself, then it will send a graphed message to its upstream router. Even graphed itself is also having join message in its side. Inside the graph message also it is having what? Join message, that now I want to join this group. Means I want to receive multicast stream for this group. So now R2 will receive this graph and it will be unicasted, and then R2 will send a graphed acknowledgement. Back to the sender, so that it can confirm that the graph transmitted by R3 has been delivered on to R2. Because see, just like OSPF was not using TCP, but still OSPF was having acknowledgement for its LSU, link state update, right? In same manner over here, there is not, it's not using TCP, but still there is an acknowledgement for graphed message. Then R2 will come to know that okay, R3 wants to join this group now. Now R2 will send graphed to its upstream router, and then R1 will send graphed acknowledgement back to R2. And previously R1 put this interface into prune state. It pruned this interface, but this time it will put this interface into forwarding state, and will start to forward this multicast stream to out from this interface. R2 will receive it here, will start to forward it out from this interface. Finally R3 will receive it here, and R3 will start to give this multicast stream towards this host. Is not it? So this is the uses of graphed and graphed acknowledgement. Now you can ask me, sir, what is the uses of join messages? What is the uses of join message? See, now let's say that this user is a member of this group, so it will keep on to receive multicast stream, right? Now R3 can poll this device by sending R3 is polling this group member by sending IGMP query messages in every 60 seconds. So it will be keep on to give report message that okay, I'm still member of this group, fine. How will it be possible for R2 to know that okay, R3 still wants to join this group, or I still need to forward multicast traffic out from this interface towards R3 for this group? How will it be possible for R2 to know that? For that purpose, let's say that R3 is still having group members, so R3 will keep on to send join message to its upstream router. Now see, routers will keep on to send join messages periodically to their upstream router, so that their upstream router will come to know that my downstream router still wants to wanna receive this multicast stream. So for that purpose, R3 will keep on to send join message towards R2. R2 will keep on to send join messages periodically towards R1. Just to indicate their upstream router to keep on to send multicast stream towards downstream routers, right? So this is the uses of join messages over here. But for join and prune, we are having a common message, right? Only fields are different. Finally, what is left? Assert message in dense mode. Sometimes what happens, let's say this is R1, this is source, R1, R2, R3, switch, R4, then after group member behind R4, right? Now R4 can receive this multicast stream coming via R1, R2, and then here, and then it can also receive it via. So R4 will keep on to receive duplicate packets. What does it mean? That R4 should receive multicast stream only from one device. See, this is not courier election. Don't think that R2 and R3 are working as a courier, because R4 is not a lane user. R4 is router. R4 is router itself. So R4 should receive multicast stream from one upstream router. You understand? So now there will be a forwarder election. In this type of condition, there will be a forwarder election. You know why? Let's say the source address is having its IP address is as 192.168.1.10, and it is originating traffic for 230.1.1.1. Fine. See, R1 will give this multicast stream to R2. Let's say this is 0 by 0 and this is what? 0 by 1. This is 0 by 0 and this is what? 0 by 1. Good. Have you understood it? When R2 will receive this multicast stream onto 0 by 0, it will create this S,G entry, that 192.168.1.10, and the group address is 230.1.1.1. Fine. Under IIL, incoming interface list, it will be, tell me, 0 by 0, and it will it will send one copy of this multicast packet out from, yes, so under OIL it will be 0 by 1. Fine. In same manner, R3 will also create S,G entry 192.168.1.10, and group address is 230.1.1.1. Fine. Under IIL, over here also it will be 0 by 0, and under OIL, outgoing interface list, it will be 0 by 1. Fine. Now this packet is multicasted from R2 onto this towards this switch. Switch will forward it towards this and towards this router as well, right? So when R3 will receive it, you will receive this packet onto 0 by 1 for same S,G entry, for which it is already having entry in its own mroute table. So for that entry, this interface 0 by 1 was under OIL, but now it is receiving that packet onto this interface. How is it possible that one single interface, one common interface, will be under IIL as well as OIL? It's not possible in any case. And if it is happening, it means that for same source and group, there is one another forwarder existing onto this subnet. And in same manner, when R3 will forward this multicast packet onto over here, it will send it towards R4 as well as towards R2. Onto R2 also, it will face same situation. It will face same problem. So both routers will immediately create, R2 will create assert message immediately over here. Just after happening this condition or this situation, once it will happen, then immediately R2 will generate a assert message. In same manner, once R3 will receive this packet onto 0 by 1 coming from R2, it will also generate a assert message. Both of them will generate assert message immediately, and assert messages will be used for forwarder election. Assert messages will be used to perform forwarder election. Now in assert message, they will include, inside assert message they will include the AD value of routing unicast routing protocol, AD value of unicast routing protocol to reach source, to reach source. So lower AD value will always be preferred. Let's say that in between R1 and R2 you are running OSPF, between R1 and R3 you are running ESGRP. Hello, R1 and R2 you are running OSPF, between R1 and R3 you are running ESGRP. So ESGRP is having lower AD value than OSPF. So forwarder will be R3. Forwarder will become R3. Let's say that you are using same routing protocol in between R1, R2, R1 and R3 as well. What will you do now? Now they will also include metric to reach source in their assert messages. So they will compare now metric. Lower metric will always be preferred. If R2 is having lower metric to reach source than R3, then of course R2 will become forwarder. R2 will become forwarder. It will be assert winner. It will become assert winner, and whoever will be assert winner will work as a forwarder. Are you getting my point? Hello? Fine. In case if metric is also common, then in assert message it will also specify their own addresses, interfaces address. I think it's lower or higher, I don't remember exactly. We can see that. I think it's higher. Yes, higher. Finally, higher IP address will be winner. So in between R2 and R3, whoever will be having higher IP address will become assert winner and will work as a forwarder. So I have taught you now uses of all types of messages in dense mode, right? Now there is a concept which is known as prune override. There is one another concept exists which is known as prune override in this manner. See, let's say this is R1, this is R2, this is R3, this is R4. Behind R1 there is a source generating multicast stream for 230.1.1.10. You understand? This multicast stream coming on to R2, R2 is giving to R3 as well as R4. Behind R4 we are having a group member, behind R3 also we are having a group member. Have you got it? So this time R3 and R4, both of them will be receiving multicast stream coming from R2. Any problem? But see, R3 and R4 are on common subnet, I mean onto a common link. Fine. Now this user have left this group, so it will generate a leave message towards this R3. Now R3 do not have any group member available. Hello? R3 do not have any group member. In dense mode, what will it perform? It will generate immediately a prune message, and prune will be multicasted with using .13. So it will send this prune message over here. Is not it? And you see, if R2 prune this interface inside OIL, then R4 will also stop to receive this multicast stream. That should not happen because R4 is still having a group member. So when R3 generated this prune message, because it was multicasted with using .13, so it will be forwarded towards R2 as well as towards R4. So basically there is a rule that when a router receives a prune message, it does not prune it immediately. It does not prune it immediately. It sets a timer of, I think, 3 seconds. I don't remember exactly, but we can confirm it right later on. It will set a timer which is 3 seconds. It will not prune immediately just after receiving prune message. It will set a timer which is 3 seconds. If it does not receive anything else within 3 seconds, then it will prune that interface for that group address, right? But see, at same time, this R4 have also received that prune message onto this interface, and it came to know that okay, I'm still having a member for this group, so it should not prune. It will immediately generate a join message. It will immediately generate a join message. So this R2 will receive this join message before expiration of 3 seconds from R4. So it will override that prune. Hello? It will override that prune condition. Now R2 will not prune this interface. So this is called prune override. Hello? When a router receives a prune message, it does not prune that interface immediately. It will set a timer which is called 3 seconds, or which is 3 seconds by default. If it receives another join message for the same group with the before the expiration of those 3 seconds, then it will not prune that interface. That's called prune override. Of course, now because R2 will keep on to send this multicast stream, so because this is switch, so it will still keep on to give it to R3 as well, and of course it will go towards R4, but R3 will not give it to anybody else, right? Again, now there is in dense mode, there is a rule of RPF, or you can say there is a loop prevention mechanism which is called RPF check. If RPF check is successful, then only your router will receive multicast packet. If RPF check fails, it will not accept your multicast packets. It will drop your multicast packets. What's the meaning by RPF check actually? See, it is used by multicasting for loop prevention. When a router receives a multicast packet, let's say it has received it onto F0 by 0. You understand? When it receives a multicast packet will always be having two addresses in its IP header, source and destination address inside the IP header. And source address will always be a unicast address. Let's say it is 192.168.1.10. and destination will always be a multicast address. Let's say it is 230.1.1.10. You understand? Hello? Each multicast packet will always be having source address as unicast address and destination address as a multicast address. Now there is a rule in dense mode. Whenever a router will receive a multicast packet onto any interface, first of all it will check its source address. It will read its source address, and then for that source address, because source address is a unicast address, it will always perform lookup in its unicast routing table. It will always perform lookup in its unicast routing table. If that source address is not reachable out from this interface only, let's say that source address is reachable from via any other interface, something like this, or from anybody else, it was receiving that unicast address, right? The best part to reach this source address is not via that interface only where it received that multicast packet. In that case, it will drop all incoming multicast packets. It will drop all incoming multicast packets immediately. Reverse path forwarding. That's called what? Reverse path forwarding. So now in case if source address is reachable out from this interface only, then only it will accept these multicast packets and will process them. So I hope that you have understood the uses of, the rule of RPF. Whenever a router receives any multicast packet onto any interface, it will learn its source address first and will perform routing, unicast routing table lookup for that source address. If that source address is not reachable via that interface only where it received that multicast packet, then it will drop all those incoming multicast packets. It means that source address of all multicast packets should be reachable, must be reachable out from that interface only where you are receiving multicast packet. That's called RPF check. So RPF check will be either fail or successful. If it is successful, then your router will accept multicast packets and will forward them accordingly. And if RPF check is failed, then your router will drop all incoming multicast packets.
This is a loop prevention mechanism, right? So, in what scenario can there be a loop if we just...
Okay, if you do not have this rule, R1, R2, R3, R4, there is a source, it will forward it to this one, because both of them are PIM neighbors. R3 will forward it towards R4, R4 can give it to R2 as well. Now R2 is receiving it from both sides, but it should receive it from only one to prevent loop. If it is receiving it from both sides, then it can also forward it towards this R1. So there will be two things now, RPF check as well as assert messages, because there can be only one forwarder, right? So you are also doing, see, in this case also there will be a forward redirection. There will be uses of assert messages as well in this case also, right? Because R2 is receiving multicast packet coming from R1 as well as coming from R4, but it should receive it from RPF neighbor only. So first of all RPF neighbor, and then after it will be depending on, you understand? So I hope that now you have understood the uses of RPF, reverse path forwarding check. It is by default enabled, you cannot disable it, don't worry about that. Now this is going to be your topology to perform all these practicals now. EIGRP is running over here as a unicast routing protocol, and this I'm using, this is your end host actually, this is right. Here there will not be any PIM in between R4 and this lane user. In same manner, this is source. These are their addresses. If you want to draw this diagram, you can draw it. Otherwise, we can continue this. So unicast routing is already done over here, and even we can take the console of multicast source and of multicast destination as well. And I am using them as a end host over here. So do one thing from multicast destination, which is 4.2 this time. Show run interface FA0/0. Interface FA0/0. Just remove these commands from here, and then after show IP route. IP routing is disabled. Ping. Right. Even you can trace route. So it's going via 24.1.2, 12.1.1, and finally 1.2 via this. It's not going via R3 because for R4 the best part to reach 1.2 is out from S1 by 0. You can move on R4 and you can check it out. This is R4. Check it out via 24.1.2 out from S1 by 0. Right now unicast routing is configured perfectly, everything is fine. Now you have to enable multicast routing first of all on all devices, like onto R1, R2, R3 and R4, because these four routers have to perform multicast routing. To enable multicast routing onto routers, there is a very simple command, like for unicast routing it was IP routing, which is by default enabled onto all routers, right? But on switches it was required to enable this command to perform routing. In same manner onto routers it is mandatory to enable IP multicast routing. Check it out in this way. This command will be used to enable multicast routing onto all devices, right? And to see that, to check that whether multicast routing is enabled or not, the command will be show IP multicast. Multicast routing is enabled. So onto all devices you have to enable this multicast routing. Fine. Then you have, after enabling multicast routing onto your device, then you have to enable PIM onto your interfaces. So on which interface we will enable PIM? S1 by 0. So move on R1 and on to interface S1 by 0, say IP PIM dense mode in this way. So in this way you will enable dense mode onto your interfaces. You understand? And then after, once you will enable PIMdense mode onto all devices, they will form PIM neighborship with each other. So right now PIMdense mode is by default enabled onto all devices. IP multicast routing is also enabled onto all devices. I think it should be enabled onto R3 as well. So IP multicast, let's check it out. Yes, oh sorry, it is disabled. So we have to say IP multicast routing. Show IP multicast, check it out. And show IP PIM interface. PIM is enabled only on loop app. That's wrong. S1 by 0 say IP PIM dense mode. Onto S1 by 1 also say PIM dense mode. Got it? Then move on R2, onto R2 as well, say show IP PIM interfaces. It is also not enabled onto all interfaces, like it should be enabled on S1 by 1 as well onto R2. So do one thing, say S1 by 1 IP PIM what? Dense mode. So it will form neighborship. Let's see neighborship how came up now. Right, so move on again R1, say show IP PIM neighbor to check your neighbor. See, it is having neighborship with 12.1.2, which is R2. Let's do one thing, let's make it transparent. See, I hope that you can see that. Is it visible? Background? Fine. So show IP PIM neighbor, check it out. And now expire, see 133, let's check it out. Expire 121, 19, 18, 17, 16, because it is kind of hold down timer, right? 41, so it is like 1 minute 45 seconds, I think so. 3.5 times, 3.5 times, because 90 plus 15, 40, 19 plus 15, 105 seconds. 105 seconds means 1 minute 45 seconds. So remember that in PIM by default your hold down timer will be 3.5 times to your query interval, to your hello interval. Right? Have you understood it now? Hello, show IP mroute. You can see this mroute table. Does it have anything? No. And for this entry will always be there on all Cisco's devices without doing anything. So don't be confused that from where it have came into the mroute table. Don't worry about that. You are not going to use this entry at all. 224.0.1.40, it will come in your Cisco's mroute table automatically just after enabling multicast routing. Even doesn't matter whether it is having any PIM neighbor or not. If it is having multicast routing enabled onto this device, then this entry will appear automatically. To see your multicast routing table, command is show IP mroute. Fine. Show IP PIM interfaces. It will show you that on which interfaces PIM is enabled. So this time this is enabled on S1 by 0 as well as FA0 by 0. See which mode is enabled. Version 2, PIM version 2 is running, and dense mode. D means dense mode. Neighbor count on serial 1 by 0 we are having one neighbor, whereas on FA0 by 0 we do not have any neighbor, because it is not, see, we are not going to enable PIM onto multicast source. As you can see on multicast source show run interface FA0 by 0, we have not enabled anything over here. Have we? Tell me. No, sorry, oh my god, I have. Fine. Then after on to R1, of course, on its S1 by 0 you are having one neighbor, that's why neighbor count is 1, and query interval is by default, and there will be a DR election, because whoever will be DR will be querier in ICMP version 1. Whoever will be DR will be querier in ICMP version 1, designated router, and DR election will be again based on, first of all, higher priority. If priority is common, then higher IP address. Based on that, DR election will be there. So on point to point there will not be any DR election. That's why on point to point on serial interface you can see DR is what? 0, 0, 0. Whereas on FA0 by 0 DR it has configured itself as a DR. Understood? Fine. Now as I said that dense mode works based on flood and prune method. It works based on flood and prune method. So what will I do? Before initializing, see, from here I will generate a multicast string for group 230.1.1.1. But before doing that, I will capture this link. This is window number 1. Then I'll capture this link. This is window number 2. Then I'll capture this link. This is window number 3. Fine. No one like R2. Does it have anything? Show IP mroute. Does it have any entry in its mroute table? No. Move on R3. Show IP mroute. Does it have any entry in its mroute table? No. Move on R4. Does it have anything in its mroute table? No. Now move on multicast source, and on this multicast source, to generate multicast string I'll say ping 230.1.1. so repeat, in source it will be having its own IP address, right? Hello, it is also kind of multicast string. You will keep on to send multicast packets. Hello, ICMP packet, but again it is a multicast packet. Whoever will be member of this group will be responsible to give us ICMP echo reply back. If there is no group member, then you will not get any ICMP echo reply. Hello, try to understand. You are generating ICMP echo request with using this group address. So whoever will be group member can give ICMP echo reply. This is multicast source now. See, and now it will keep on to send it, right? So first of all, it flooded it out. You can see window number 1. See, it have sent this ICMP request. First packet, only first packet. See, in it is having source is this and destination is this. Is not it? Hello. Even what can I do? I can say stop. Onto window number 2 also I will say stop. Onto window number 3 also I will say stop. So what, as I said, that it works, dense mode works based on flood and prune method. So very first packet was flooded out towards the network, throughout the network, and then R4 have sent a prune message back to R2. R3 have also sent a prune message back to R2. Then R2 have sent prune message back to R1. Window number 1, this first packet, ICMP, right? Hello. Source is 1.2, destination is group address. Fine. PIM hello message is multicasted. Join prune is also multicasted. Hello. Open it. Hold down timer. 105 seconds. Right? Fine. DR priority and all these things. Fine. This is hello interval. And see, PIM itself is using its IP protocol number, 103. IP protocol number is what? 103. And I think we write down 112. It's 103 actually. Right? Fine. It have given prune message back. See, you can open that. What is it saying? Its type is what? Join prune. See, there is only one message for both of them. Join prune. Type is what? 3. PIM options. And this is for prune, number of prune, not number of join. Number of join is for 0. It means this is a prune message actually. And it is saying that, okay, prune for this group and for this source address. So now, if you move on R1, and if you check its route table, show IP and route table. Check it out. It have created this as G entry over here. Hello. Under incoming interface list is what? Fast Ethernet, because it received it on F0 by 0. Under OIL it is S1 by 0, but it is what? Because it received prune message onto this interface for this S, G entry from R2. In same manner, when R2 received this multicast packet onto this S1 by 0, so it will be under incoming interface list, and under OIL it will be S1 by 1 as well as S1 by 2. But on both interfaces it have received prune message from R3 as well as from R4. Move on R2, check S, route table now and see S, G entry is there. Under IIL S1 by 0, under OIL S1 by 2 as well as S1 by 1, because by S1 by 1 R3 is connected, by S1 by 2 R4 is connected, and both of them have forwarded what? Prune message. Tell me.
Is there any information that will tell that this router is pruning the upstream link? I can check it from R1, but from R2 no.
Now. Right? But remember that RPF neighbor, see, onto R2 is what? So whenever it will send, it will require to join that group, it will send the join message to this RPF neighbor only. Understood? Hello?
So it will create a star G entry as well as
S, G.
S, G entry, both.
Yes. Then after, you can move on R4 as well. Show route S, G entry. See. RPF neighbor is 24.1.2 because this is the best, because R4 could receive, because it is having PIM neighborship with R2 as well as R3, so R4 can receive packets from R2 as well as from R3, but RPF neighbor is what? R2. However, in this segment, see, in this segment there will be a assert winner, because R4 is also giving to R3, R3 is also giving it to R4, so there will be a forwarder election, and assert winner will always become forwarder. So now there will be, R3 will send assert message out from S1 by 1, and R4 will also send assert message out from S1 by 1. And see, AD value is same, EICRP. Even from R3 and R4, the cost to reach source is also same. Finally, election will be based on higher IP address. That is why R4 have won this election. R4, this A, assert winner. If you move on R3, you will not get that assert winner. However, now it does not have any S, G entry right now. It should have that. Even it does not have that entry as well. Okay. Wait. That's a problem actually. Even it is also not having now. That's the problem of this CNS actually. It is having that actually. It's having. But now there will be a problem. No one will be able to receive this multicast stream now. If I wanna join it on multicast group member, I will move there. See, this is group 230.1.1. I'll move on multicast group member to join it onto FA010. I'll say IPIGMP join group is what? But will it be possible for it to receive? See, onto R4, say show IPM route. Nothing. It does not have anything. Now this is the problem in this CNS now. That's why it is not. I'll stop it. I'll move on R1. I'll say clear IP M route star show IP PIM neighbor. That's fine. Show IP M route. It does not have anything over here now. And then once again I will move on multicast source, and then again I will say ping this, and see this time it have started. See, that's the problem. Now you are getting replies from where? 4.2, because 4.2 have joined this group this time. And to join a group, command was in Cisco iOS. Otherwise, if you are using a laptop as a host, then here let's say that you are having your VLC. Where is VLC? And if you want to join any group, like you want to play video over here, then you have to go to media, then you have to go to stream, and then you have to go to network, and then you have to enter your network URL and all. Something like that. From here, open network stream, you see. Like 230.1.1.1. Right? So in this way you can do that. So it will join that group automatically, right? Don't worry about that. And once again, see, still skip. It is receiving replies from there. It means multicast stream has been delivered on over there. So I hope that you people have understood that how this dense mode really works, right? See, onto routers, by default, IGMP is not enabled onto any interface. So it will not be possible to join a group onto group member with using this command without enabling PIM. To enable, see, this is recommendation only on routers, not on PCs. On PCs, IGMP is by default enabled. But if you want to enable IGMP onto your routers, then it is mandatory to enable PIM. Without enabling PIM, as you can see that here, show run interface FA0x0. See, I have enabled PIM. Dense mode. Then after IGMP was enabled over here. Then you can see that why I configure this AC here, because I don't want to let these two routers to form PIM neighborship, because I don't want to run PIM between them. That's why what I did, I filter out PIM packets. I filter out PIM packets with this AC here. Show IP access list, you see. So that, because PIM packets will not be received by this source from R4, so it will not form PIM neighborship. Because see, in between PC and router, there will not be any PIM neighborship. So to achieve that, actually I have just filtered these PIM packets with the help of ACL. But it was mandatory for me to enable PIM onto routers interfaces just to enable IGMP. Hello, see, onto multicast source, sorry, group member, say show IP IGMP interface. So this is the interface on which IGMP is enabled. FA0x0. If I do one thing, go to FA0x0, no IP PIM, then small. IP IGMP. IP IGMP interface. Is there any interface where IGMP is enabled? Let's see that after it will get enabled or not. Okay. So if you join any group, it will get enabled automatically now.
Still it will be able to.
Yeah, it is enabled, and it should. See, it is getting replies from there. It means it is not mandatory to enable PIM onto Cisco devices as well. You can simply join a group by just after configuring this join group command, IGMP will get enabled onto this interface automatically.
So we can enable PIM on these interfaces and enable IGMP join and loop back.
Onto?
I'll do IGMP join and loop back.
Of course, you can join your group onto loopback interfaces as well. Like you can move on R3 and onto its loopback. Say IP IGMP join group 230.1.1.1. Now see, replies will come from two different devices now. However, you are giving only one packet. See, I will capture this link once again. You will see that only one multicast packet is going, but multiple are coming back. See, it's not it. Hello, it is giving only one echo request, but two replies are coming, which means that you are still sending only one packet, but it is delivered onto two different users. That's what the meaning by multicast.
Like a member now.
Member now, exactly.
And graph messages will be sent by.
Of course, R3 too, because R3 pruned itself from this. I mean, it sent a prune message to R2. Let me show you actually that it will send it. I'll capture it, and then I will move on R3, and once again I'll say no, and you see that onto here it will send a prune message. See, it have sent this prune message now. Prune, number of prune, right? And then after, once again I will move on R3 and I will join this group. Sorry, yes, I have joined it, and see, this time graphed. and graft acknowledgement, and these two are unicast messages. And once again it has started to receive ICMP request, right? I mean those multicast packets. Right? Actually, if you open graft message, it itself have join message, number of joins, not prune, right? However, it is type number 6, but still it is having join information in it. Hello, and see, it will keep on to send join messages periodically as well. I will show you. Just to inform, it's a piston router that still I'm joining this group. This is hello, fine, hello. We have to keep an eye on to join message.
SLAR की क्या होता है, जो 10 सेकंड की प्लाई होता है।
Only hello. It have not given any join message yet. If I move on R2, if I check route table, S, G entry dense mode. See that, but finally you have came to know that okay, how is it working, right? Like what is the uses of graft message, what is the uses of assert message, graft acknowledgement, and join prune, right? Everything. How to enable ICMP, how to enable PIMdensemode, right? Everything. Now let's discuss about RPF failures, RPF check. Fine. Everything is working fine now. You can see that you are getting replies from there. You can move on R3 now and you can disjoin this group from here. So you will receive replies now from 4.2 only. See, I have stopped to receive replies from 23.1.1.2 or what 23.1.1.3 actually, right? Fine. Now for R4 is RPF neighbor is what 24.1.2. It is receiving multicast packet onto S1 by 0. Onto S1 by 0. Are you getting my point? And its best path to resource is also via S1 by 0. Great. Now what will I do? I will disable PIM over here. I'll remove PIM from here. So it will lost PIM neighborship in between R2 and R4. So it will start to receive this multicast packet via R3 now. And if it receives via R3, then it will see that my best path to reach it via S1 by 0. Let me do that now. So for doing that, I will move on R4. I will say debug IP and packet. Debug IP and packet. This is kind of debug IP packet, right? And then after, what will I do? On to R2 itself, on S1 by 2. See, this is S1 by 2. I will remove this PIM. No IP PIMdensemode. In same manner, I will move on R4 on to S1 by 0. No IP PIMdensemode. So on to R4 also PIM neighborship will go down. Show IPM route. Incoming interface list is nothing. It has stopped to receive anything over here. Now do one thing, just stop it and move on R1. Say clear IP mroute star. Move on R2. Say clear IP mroute star, just to clear your mroute table. On to R3, clear IP mroute star. On to R4, clear IP mroute star. Now move on source. Once again generate multicast stream. Fine. Move on R4. It have shown you what? RPF lookup failed. That is why show IP mroute. It is having SCOMAG entry, but RPF neighbor is what? 24.1.2 according to the unicast routing table, right? But now incoming interface have become what? Now, because it is receiving packets onto S1 by 1, whereas the best path to reach 1.2 is out from S1 by 0.
आउटगोइंग लिस्ट में भी S1 by 1 क्यों दिखा रहा है?
Because now S1 by 1 is not under incoming interface list, because my RPF neighbor is on to different interface. That's why. So now it have dropped all incoming, it is dropping all incoming multicast packets because due to RPF lookup failure. To solve this problem, now you have two options: either enable PIM in between R2 and R4 as well, or do one thing, configure R4 so that its best path to reach 1.2 will become via R3 itself. Apart from that, you can manipulate your RPF by configuring static mroute as well. By configuring static mroute as well. Like, it is performing lookup in its unicast routing table to know about, for its RPF check, right? For its RPF neighbor. But if you configure it statically, then for static, its AD value will be 0. For static mroute, see, this is not a static route, unicast route. This is static mroute. For static mroute, its AD value is what? 0. And the AD value of that route which learned from EICRP is what? 90. So it will prefer that static one, right? So what can you do now to solve this problem on 2R4? You can say IP mroute for what? 1.0, this network, right? Subnet mask was, because source is this, right? And for its next hop is going to be now 34.1.3. It should be your RPF neighbor, right? So in this way you can define your static mroute now. And now it will prefer this static mroute. You see, forward means that it have started to forward your packets now. It is not dropping all incoming multicast packet, because if you check show IP mroute, now RPF neighbor is what? 34.1.3, and you configured it via mroute. And you see, replies have started to come from there. It means that multicast packets have started to deliver on to 4.2. Understood or not? Done? Are you comfortable with it? Now try to perform all these practicals by yourself, right? So that in next class I can perform some more advanced practicals, and in next class I will start your sparse mode as well. Have you understood it or not? For sure? Great. Fine.